Okay, per Roland's requirement, so I'm making this video for sets. So we're going to do this question 5, but before that, let's just remember, we're in a new module talking about sets, right? A set is a collection of things. So like this one, U is a set of numbers, right? It contains 1, 2, 3, 4, 5, 6, 7, 8, 9. And we use these braces to representing a set. So this is a set. And A is also a set. B is also a set. C is also a set. So sets, we use capital letters to represent. Right? To the sets. Then in the set, we call elements. Right? So 1 is an element in set U. 2 is an element of U. Right? 2 is the element of A. 4 is element of B. So we call those objects in the set elements. Then subsets, right? Sub means smaller. So subsets means a set is smaller than a set. Let's see here. We see A is a subset of U. So how do we represent that? We say A is a subset. So they use this notation. Subset of U. Why? Because the 4 elements A has, 2, 4, 6, 8, are contained in U, 2, 4, 6, 8. But U has more. So A is contained in U, or A is a subset of U. So A is a subset of U. And also B, right? We see B is also a subset of U. Because 1, 3, 4, 5, 7 is also contained in U. And C is also a subset of U. So A, B, C, 3 of them are all subsets of U. So in contrast, we can call U as a superset of A, B, and C. Or even better, we see U is a universal set, right? Because see, let's use different colors. So let's use red color for A, right? A contains 2, 4, 6, 8. So 2 is here, 4 is here, 6 here, A is here. So A is a subset of U. And then B, let's use blue color. Oops. B contains 1, 3, 4, 5, 7. So 1, 3, 4, 5, 7. Right? So B is contained also in U. B is a subset of U. C, let's use black color, contains 7 and A, and 7 and A is here. Right? So U contains A, B, C. So we can consider U as a universal set for this question, universal set. What else we have? So the operations. So talking about sets, we have 3 operations. One we call uni. A uni. So this is a uni operation. This is a uni operation. These 2, uni operation. Then we have intersection. Intersection. This intersection. This intersection. This intersection operation. And we have another one called complement. The A complement means the elements not in A, but in the universal set. Let's use this example to find A complement. So we're treating U as a universal set. So A complement means the elements in U, but not in A. So let's see. So 2 is in A, 4 in A, 6 in A, 8 in A. So what's not in A, but in U? 1, 3, 5, 7, and 9. So we call it A complement. So we could see A union A complement is the universal set, right? So what's in A? So elements in A, elements not in A, but in the universal set. So A union A complement always equals to, or a set, for any set, union its complement always equals to the whole set, universal set. So 3 operations are sets. Now, okay, now let's try this question. So the first one, A, is find A intersect B. Right? A intersect with B. I want to change the red color. A has 4 elements. B has 5 elements. So intersection means the common elements. So elements in both. Elements in both sets. So let's see. 2 is only in A, not in B. 4 is in A, also in B. So we have a 4 in the intersection. Now let's say 6. 6 only in A, not in B. A only in A, not in B. 5, 7 only in B, and 3 and 1 only in B, not in A. So there's only one element in the intersection of A and B. So A intersect B is 4. Now let's see A complement. Right? Another way of writing complement is A prime. So sometimes we write as A raised by C or A with apostrophe. Okay, both mean complement. Okay, so A complement union B complement. So let's find A complement first. So A complement is the elements not in A, but in the universal set. Right. So compare U and A. We see 1 in the universal set, not in A. So 1 is not in A, 3 not in A, 5 not in A, 7 not in 8, and 9 not in A. So those 5 elements not in A. So we call them complement of A. The same way, let's find the B complement. B complement, or use this apostrophe. So B complement means the elements not in B, but in the universal set. So B contains 1, 3, 4, 5, 6. So 1, 3, 4, 5, 7, not 6, 7. So what's left? So B complement has 2, 6, 8, 9. Right, that's B complement. Now we want to union those two. So union means that all the elements both in A and in B. So in A, let's write in A, both in A complement and B complement. So in A complement, we have 1, 3, 5, 7, 9. Now we're writing the elements in B complement of 2, 6, 8. Now 9, but we already have 9 here. So we don't need to write 9 twice. So that's it. Because remember, in a set, it has to be distinct elements. So the elements has to be distinct, different. Okay, if the same, we'll only write once. Okay, we have 9 in A, 9 in A complement, 9 in B complement. When we union them, we only write once. So A complement union B complement is 1, 3, 5, 7, 9, 2, 6, 8. I think that's equal to U. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, well, 1, 2, 3, oh, no 4. Doesn't equal to U. Right, no 4. There's no 4 there. All right, so that's A complement union B complement. Now, so that's a C. Now let's see E. Oh, I didn't follow A, B, C, D order. Let's find A intersect with C first. So A intersect with C. That means the elements in A and also in C. So let's see. A, so let's focus on A and C. Well, C has 2 elements, 7 and 8. And A has 8, no 7. So the intersection of A and C is just number 8. Right? A is in set A is in set C. So A is the only element in the intersection of A and C. Now let's find A union B. A union B, let's write A first for union because we need to contain all the elements in both. So write A first, 2, 4, 6, 8. Now let's write B. 1, 3, 4 is already there. 5, 7. Right, that's A union B. Now we want to take the intersection of those two sets. Well, that's easy, right? A intersects C only with only one element, 8. So A is indeed in A union B. So that intersection of those two, just number 8. Now let's see B complement. We already found B complement here, right? B complement means the elements not in B, but in the universal set. So you see 1, 3, well, let's just do one more time. So 1 in B, 3 in B, 4 in B, 5 in B, 7 in B. What's left? 2, 6, 8, 9. So B complement contains 2, 6, 8, 9. 4 elements. Okay, A minus B. Okay, A minus B equals to the elements in A, but not in B. The elements in A, not in B. But usually we don't do A minus B because the 3 operations are union, intersection, A complement. So if we want to do A minus B, usually what do we do? So the elements in A, but not in B. We want to do this. We want to do A intersect with B complement or B apostrophe, okay? B complement. Why? Because the elements in A, but not in B. So usually we don't use this because minus is not an operation for sets. So we want to write this way, A intersect with B complement or A intersect with B apostrophe. So let's see. Elements in A, not in B complement. Well, this is B complement. So this is A. So let's focus on A, oops. Set A and set B complement. the intersection of those two. What are the elements in both? 2, 6, and 8. So they equal to 2, 6, and 8. If you want to use mathematical thinking, as this question written as A minus B. We don't do A minus B. Oops, why erase that? So B complement is 2, 6, 8, 9. That's B complement. So A is this, right, minus B. So 2 is gone because minus 6 is gone, A is gone. So 4, then we have 4 left in A, but we still have 9 left in B. Oh, hold on one second, I'm doing it wrong. I'm not doing B complement, I'm doing this. I should focus on this. I should focus on this and this, these two, right? A minus B. So 2 is in A, not in B. 4 is in A, also in B. 6 in A, not in B. A in A, 8 in A, not in B. Okay. So we have 2, 6, 8, 2, 6, 8. But again, in sets, we do not use this notation. Okay, we use A intersect with B complement, which means elements in A, not in B. Right, because B complement means elements not in B. All right, that's this question. Hope this is helpful for you. Now let's see 6, actually. 6, list all the subsets of TIM. Remember, the cardinality of a set is how many elements in the set. So the cardinality is 3 for this set. And that means it has 2 raised by 3 subsets. 2 raised by 3 is 2 times 2 times 2 is 8. So if we make a list, we start with empty set. Then with a single element. Then with 2 elements, TI, TM. Then IM. Then 3 elements, TIM. The set is itself. So subsets of a set always contains 2 special sets. Empty set and the set of itself. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So those are the all subsets of TIM. Okay.